Hello everyone, welcome back to my channel. So now we are almost done with the arrays and we have also solved most of the array based questions that can be asked in the interviews. It's now time to move to linked list. Okay. By the way, if you have any other array based question that you want answers of, let's put them in the comment section and maybe we can try to make a video on that. Okay. So now let's start with what exactly is a linked list. Going in the terms of definition, linked list can be called as a collection of nodes that are randomly stored in the memory. Let's try to understand the definition of linked list by understanding why exactly was linked list ever required. Okay, so for that, imagine that you have a RAM of 16 KB. You are using, let's say, 2 KB for listening to music, and you are using maybe 4 KB to play a game. I know it's not realistic, but let's try to get to that. Okay, so if I ask you that, can you give me an array of size 6? Basically you want 6 elements in an array, each of size 1 KB. So can you create that in this RAM? It should be possible, right? I mean, you can see that you have almost 10 KB of free space in your RAM, but via array can you do that? I don't think you can, because array has a small bit of requirement that it requires a contiguous memory allocation, though it does have its own pros that you get random access and all, but this is one of its cons. You can't really create an array of 6 KB even though you have that much memory. You can't do that. So that's where linked lists come into picture. What linked list says, go back to this definition, that it can be present at a random location. So with linked list, you can say that, okay, I'll create 1 here, 2 here, 3 here, 4 here, and then 5 here and 6 here. I mean, linked list will be creating these, it will be creating 6 elements, but they can be randomly placed anywhere in the memory. So that is why linked list were ever required. Now let's try to understand the exact data structure of linked list, right? But in order to do that, how about we sort of start comparing it with the things that we know? Like, let's compare a linked list to an array and create what a linked list is. All right, so imagine that this is your typical array, right? You have a few elements and all. So this is your indexing 0 1, right? So what exactly is this first, what is the first index? Let's call it an element for now, right? And these elements have some sort of data in that, right? So this is your typical array. How do we access them? You know that it's contiguous and you can just randomly pick the index, and after that you can access it. Now let's try to build the linked list data structure using this array. So as I've mentioned, linked list is called as a collection of node. Now what is a node? The most simplest way of explaining a node would be this. A node contains sort of 2 fields in it. Okay, the first field is known as, let's call it data field. This data field is exactly similar to what an element in an array contains. This can be called as its copy, right? Now what is this second field? This is the field that enables that random allocation in the memory. This is, let's for now call it the address field. This can be used to, this is basically used to store the address of the next node. There are a lot of linked list, there are a lot of types of linked list available. For now, we are simply talking of singly linked list. Okay, so yeah, this is your data, this is your address, and this entity is known as a node. Yep, that is all that you need to know about linked list. Linked list is a collection of nodes. So when you actually create multiple set of these nodes, it creates a linked list. This address is basically stores the value of a next node. So it sort of points like this, and again the next node will definitely have an address to the next node, and it will point it like this. And if let's say this is the last node of the linked list, it sort of points to null. Null indicates that, okay, this is the last node, now you don't need to do anything. So this is your typical example of a linked list. Hope that makes sense, right? So now let's try to distinguish between a linked list and an array by understanding their pros and cons, right? You need to understand this so you are aware of which data structure to use in your question, right? So in order to explain this difference, we are going to use the two most basic operations, which are insertion and searching. Okay, so let's start with an array. Let's say that you have an array of size 3. You have these elements 1 2 3. Now let's say if I want to insert an element on this, what is going to be time complexity? Remember, this is not a vector, this is an array, right? An array are, they are sort of static. You have initialized their size at the very beginning, right? You can't really make them dynamic as of now. So but still you want to insert an element. What will you do? You'll create let's say that if this array was of size n, but we know that as of now it's of size 3, but still let's say n, you'll need to create an array of size n plus 1. Okay, let's say I want to insert 4 in between. Okay, um, so what you'll do is after that you have n plus 1, which means you have sort of 4 values here, and after that you can copy 1 here, put 4 here, and then 2 here and 3 here. Now what is going to be time complexity? The insertion operation, I mean putting the 4 is only of order 1. However, you are copying all these elements 1 2 3, so that will take the order of n. So insertion in an array is basically equal to the order of n. Okay, now what about linked list? So let's create a linked list and let's take the same numbers. Okay, so this is your 1 will point to 2 will point to 3, and the address of 3 is going to be null, right? So I want to insert 4 in between 1 and 2, right? This is again your node, it contains 4. Now how are you going to insert this 4 in between? You'll make your 4 point to 2, right? This is your address. You'll store the address of 2 in here, and after that you'll make your 1, instead of pointing to 2, you'll make it point to 4, right? So after that it will become 1 4 2 and 3. This connection is broken because it can only store the address of one node, and now it's storing the address of 4. Okay, so after this your list become 1 4 2 3. You have sort of only used 2 operations as of now. So if it is a constant number of operation, it can be said to have a time complexity of order of 1, right? So we have seen that insertion is really easy in linked list. It is only of order of 1. However, in arrays it is of order of n. Okay, so here we 1 goes to the bucket of linked list. Now let's talk about the searching. Do remember that searching was like the biggest benefit of arrays, right? You get that random access anywhere. You just need to know the index of that element and you can access it in order of 1, right? So I'm not really gonna put a lot of emphasis on this, but the searching in an array is basically order of 1. You need to know the index and you just do this array and that particular index and you are able to get it. Now in linked list it becomes a bit tricky. In linked list, let's say 1 and 1 points to 2, 2 points to 3, and let's say done. Okay, so now if I want to access the third element, what will I do? I will start from the first element. I believe I forgot to mention this in the starting, but you only have the address of one node in your linked list, and that is of the start node, right? I wasn't really focusing on the terminologies because as of now my main focus is for you to understand what a linked list is, not on the terms and all. But still, this is a start node and this is the only address that you'll know. Okay, after this you don't really know the address of the third node, the one that you want to access. So what will you do? You go to your start and then you know this is your first element, so then you check the address, you move to the second node. Okay, you know that this is the second node, I want to access the third node. After that you move to the third node and you sort of print the value, right? So in array, what was simply accessing a of 2, in linked list it has become sort of the whole traversal of the linked list. So the searching, the time complexity of searching in a linked list is going to be order of n. Now this goes in the bucket of array. So for both of these basic operation, we have seen that insertion is a bit more expensive in array. However, searching is a bit more expensive in linked list. Now depending on your question, what are you supposed to do again and again? Are you supposed to insert it again and again, or are you supposed to search it again and again? You can choose your data structure and be smart about it. Okay, so that was all for the difference between a linked list and an array. Now let's try to revise what a linked list is. Okay, so a linked list is a collection of nodes that can be randomly stored anywhere in the memory. This is your node, right? A node contains of 2 fields, value and address. Value is basically the data that you want to store, and address contains the value of the next linked list. Remember, it's a collection of nodes. Okay, so we are supposed to have a lot of nodes here and there. Okay, and yeah, VA and VA. Okay, the last node will have its address as a null, pointing out to us that this is the last node. Okay, and each of these each of these nodes, they will have an address, right? Let's say for now this is A, this is F, and this is C. This is the address. So as a user, you will only have the address of the first node or the start node. Okay, and in the address field you'll have the address of the next node. So for the first node you'll have F in the address field, and here you'll have C, and here you'll have null. So yep, this is your linked list. In the next video onwards, we'll be focusing more on the coding part. We'll code out all the basic operation of a linked list, and after that we'll be attempting question based on linked list. So yep, that was all for now. Thank you for watching. Take care.